Sure, so welcome back. I hope you had a good night. What we want to do today for the second session, I already told you yesterday, we want to have a look at specific Python libraries which can be used as tools within such a data steward-like pipeline, where you start with messy data handed over by researchers, and you want to end up with validated data, which is checked and cleaned, which has metadata, and which can be put up to any repository like Zenodo, for example, right? And I want to show you how you can do it with JupyterLab and Python. But again, this is just an option. You don't need to do it with JupyterLab, and you don't need to do it with this specific Python libraries I'm going to show you. It's just a selection. I will show you later that there's a whole universe of Python libraries implemented and programmed for nearly everything, and it's up to you to select the best fitting ones, right? So for today, this was what we had yesterday. As a short recap, I introduced you to JupyterLab and the handling of JupyterLab. I introduced you how you can use UV as a software tool to start and install JupyterLab and Python in a virtual environment. We checked how to handle notebooks, add the different types of cells and use them, how to execute cells, and we used our AI assistant to not only answer questions, but also to draft code in a separate code cell, and to also draft actual documents like markdown files or whole Jupyter notebooks doing data exploration stuff, for example, right? This is where we ended yesterday, and this is what we want to do today. I want to show you different Python libraries. Don't fear, we are not going to program like anything by ourselves. We let, again, our AI assistant do it. We want to check what it did. We can also ask the AI assistant to check by itself what it did, right? And we want to end up with a tool belt which helps us for all those things. Right? Once again, the training materials, I think they are clear right now. You may have them in a browser. I don't think we need them anymore today, since you all have this secrets file provided and prepared, right? Okay, this is the expectation management, which it applies to today, right? And for today, we want to use Biobob again to do all this data validation, create data quality reports good morning, in a really fine HTML file which can be distributed and interactively watched. We want to do some data cleaning, create metadata and a data package, and then let's see how the time flies by. We want to use the Zenodo API to load such a metadata data package actually to Zenodo to upload it, right? Okay, so this was this. We are quite ahead of time. Any questions up to here for what we are planning to do today? Nice. So yeah. Yeah, definitely. I went to bed a bit earlier, I think, than you, right? Okay, what we want to do now again, taking our time to do the technical setup check again, so that everyone ends up with the running JupyterLab instance loaded with the secrets file and this environment variables available, so that we can use our AI assistant in JupyterLab, right? Okay. So, oh, icons, nice. We don't need them. So what I want you to do again is, first of all, find the folder where you worked in which you worked yesterday, like the sessions download, right? Now I want you to open a terminal at this very folder, depends on your system. I think also Windows have this new terminal at folder, where we end up with this. You can also check again if all the files are there. For Windows, it's dir. Just so that you know what those files are, right? This .venv are all the Python files for this virtual environment. This .ipython notebook checkpoints are temporary and cached files for JupyterLab, so that if you reopen JupyterLab knows where you left it the time you closed it, so that the correct notebook with the correct intermediate state is opened, right? And we have our PyProject terminal and our secrets files. Everyone is having this, right? Anyone not? So, and we want to start JupyterLab again with UV run. We want to use our secrets file for the environment variables.
If I have open, I didn't close it yesterday, so
you can
from the point of view of
you can check if it's still available since it is.
But from point of view of some memory or something like which
we will see right away if the environment variables are still available, but if it's still running, then you can just use this, of course, right? Yes. Sure.
I need to get to the session download.
Let's see where you are. So you are here. We want to have right click, and there is also on Windows, there's Open Terminal. It's quite convenient. So this should be fine, right? And if you run this now, uv run -env -file. You should end up with lots of messages, and then JupyterLab should start. And as you can see, the last time, or the last file I had open in my case was the secrets file, and this was stored in this IPython notebook checkpoints. So JupyterLab knows where to start again. Okay, for today, we are in session 2, right? So technical checkup, everything works for everyone, right? Great. So what we want to do today, I just show it again in the slides, so just that you have an overview to this stuff we want to do, this data stored pipeline, so that you know what I'm talking about. We start with kind of raw data, which may be a messy CSV file or a messy Excel file, missing data, whatsoever, typos. And what we want to do first is we want to validate it against a schema, right? So we can use a schema as a kind of a data contract, so that we can check if data applies to a certain schema, and based on this, we can do a quality report, where we can also apply some basic cleaning. For example, fixing typos, stuff like this, or reformatting data types, right? What we probably don't want to do is fill in gaps, right? Because you're just the data steward, not the researcher. You don't really know what about the missing data or what the case is for missing data, so you can't really fill in. For numbers, you may just do something like, okay, there's missing data in a column of numbers. I just fill in the median or the mean value, but this may be wrong, right? So we don't want to fill in, but we can fix obvious typos, obvious malformatted data formats, stuff like this, right? And then we want to really create a quality report, which can be handed over to other people. Then we want to package the whole thing, create metadata, which describes our data set in a good way and makes it findable, right? And then we want to use our AI assistant to draft an according part for a data management plan, and then we want to deposit it and create a DOY, so that it's also findable, so for the FAIR principles, right? And for all those, we want to use our AI assistant, which drafts the code and does the stuff, and we just check what the results are, right? So this is what we want to do now. So I want you to, where are we? Open the notebooks. I need to make it a bit bigger, right? So open the folder session 2. There we have notebooks, and there we have the first notebook, toolbelt overview. So this is a lot of text for what I just showed you with the icons, so that you can read it by yourself later on. And we want to use different Python libraries to do this. Yeah? Python library is just a small bit of software which does some stuff. We want to do, or we want to use Pandera, FG data profiling, and frictionless, right? So how do I know what Python libraries are available for my task, and how can I check how to download them? How can I check if they are valid? Stuff like this. In the Python universe, there is a so-called Python package index. You may open it. It's pypy.com, so Python, py, py. Oh, pypy.org, sorry. It's .org, not .com. I'm sorry. It's an interactive session, right? So, this is the official Python package index where you can search for Python libraries, Python packages, and investigate them any further, and then decide if you want to use them, download them, use UV to install them, right? So, for example, I can search for example, data validation, right? The keyword search is also a bit fuzzy, so it also finds libraries which somehow has data validation in their README, stuff like this. And now, unfortunately, it's up to you to decide, okay, I want to work with this library whatsoever, right? So how can I decide whether a library is good and usable? Because there's also a lot of rubbish out there, and there's also a lot of malware out there, right? So because each and everyone can put a Python package to this index. It gets checked, right? But there are also things going through, right? So a first good idea would be just click on it and then check whether there's a proper project description, right? So there is no project description at all for this library. So this is kind of, I would use it because it's not described how to use it, who did it, whether it's kind of good or not good. I mean, there are some details about who maintains it, who implements this software, stuff like this, but this does not make a good impression. Also, the last released version was in 2021. In the best case, you want to use libraries which are maintained on a regular basis, right? Which get security updates, stuff like this. So you may probably want to end up with something like 2025 at least, right? So this is not a good idea here, right? And this is at least a starting point to search for. You may also just use a web search for Python library for data validation. Then you get lots of articles and lists, and based on this list, you can check in the Python package index which Python packages you want to use, right? So for the case for Pandera, we can just search it. This is also a lightweight, flexible data validation and testing tool for data objects. So this is something we want to use. And this looks a bit better. Okay, the image is not rendering, but last version was in April this year, way better. There's a proper explanation, how to install it, how to get started, how to use it. And there's also lots of different Python versions supported. This looks way better. This is something I would use, right? So just for your information, if you are heading to use different Python libraries, this is a starting point to check them, right? Okay, any questions to PyPy, Python package index, right? Everything what's listed there can be installed with UV. Like, for example, here's the installation, how to installation with UV, just UV pip install or UV add, and then you can do this, right? Okay, so this is what we want to use, those libraries. This is our data steward pipeline I already described, right? Explore, validate, report, clean, package, and deposit. And we want to use those tools for the different pipeline steps. And we want to start with initializing our AI assistant again, right? We did all this with rerun again, so the first step in a notebook, and that's unfortunately the case. If you want to use such tools in a notebook, you need to import it for each and every notebook. This got not transferred from one notebook to another, right? So we can execute this. We want to check here, okay, it uses the correct endpoint. We want to use the model mini right now. And you don't get an error. And what I do in such cases, this is just a short like check if it's alive, right? I just ask it something and I expect an answer, and that way I know, okay, the AI assistant is connected to the API endpoint and I can actually use it. And as we remember from yesterday, it's already loaded with our really fine-grained system prompt for Data Stewardship Assistant, right? Okay, so what are we want to work with? I have prepared, or not I, it was Claude. ChatGPT equivalent has prepared a raw incoming dataset of field samples. We can check what this dataset looks like in our file browser. We can go one up, data, field samples. JupyterLab also allows to open CSV files, for example, in a good view. And as you can see, we have a couple of columns where samples are collected by researchers. There's a sample ID, there's a species. It's about penguins again, right? We have islands, date collected. And just by eyeballing the data, we can already spot a couple of problems with the data, right? There are missing values. We have also typos. For example, this species is typed with 3 O's instead of 2. We have different types of date formats, which may be a problem for us, right? We also have a body mass, which should be grams, but sometimes there is a G for gram, but mostly there is no G, it's just a number. And also for this flipper length in millimeters, we have sometimes not just missing values, but there's null actually written into it, right? So we can already have a look just by eyeballing, okay, this data is potentially problematic. If we want to validate it, we need to, or we want to validate it, if we want to validate it against the schema, this is something we need to tackle, right? So just by eyeballing. Now we want to use, this is the case, if we have just a CSV with like 20 entries, this is really easy for a human being. But let's imagine you have a file several gigabyte big. You can't just by eyeballing find the errors, right? So we want to use our AI assistant to check our data. For doing this, we need to import this CSV file into a so-called pandas data format. Pandas is a Python library which helps us handling tabular data, right? So, and here comes the point. If you do not understand what this code cell does, you may just ask your AI assistant. And you can do it by just adding this multi-line prompt, Bob, right? And then, what does this code do? Explain for a Python beginner. So, this is now a multi-line prompt for our AI assistant. Yeah? The very moment we put those magic commands, percentage in here, all these are multiple lines for just one prompt. And Bob just knows now, okay, this is where the code starts. And my task is to explain this code to a beginner. We can execute it now, and hopefully it just puts out a short answer. Okay, it's a bit longer, but it does the explanation step by step for a very beginner. And now it tells me, okay, import pandas SPD, first line. Pandas is a Python library to work with tabular data. Yeah? And the SPD part is just a nicknaming for the import name. You can import pandas or can import as PD, and in the following you just name it PD, right? This is the second line is where we want to read a CSV file. There are also different other types. You can use pandas, for example, to read the Excel sheet. You can use pandas to read lots of different data types, right? And it's explained what it does in detail, and then we just want to print how many rows and how many columns it has, and we want to print the first 10 lines. So this is what this code does. Now that we know, we can just remove this line again. Now it's a normal code cell again, and we can execute this code cell now that we know what it does. And if you encounter an error right here telling you pandas is not available or module not known, then you need to do this again, right? UV add pandas. But as you can see, this code cell does exactly what BioBob did explain to us. It shows what the shape of the data is, how many rows and how many columns, and it just shows the first 10 lines, which we also did via eyeballing, right, by opening the CSV. So now we have our data loaded into this small object called DF. It's short for data frame, right? You can also name it whatever you want. So now our data is available in our Jupyter Notebook. Yeah? It's stored in an object in memory, right? So now we want to use our AI assistant to do the same we did, eyeballing the data and spotting any problems, right? We do this via such a multi-line prompt again. And here you remember yesterday, we augment our prompt, curly brackets, and put the whole data set in here. And here, attention please again. Right now, it's just a very small CSV dataset, 100 lines, 9 columns. This is fine for the context length, right? But if you put a dataset several gigabyte big into here and feed it into a prompt and feed it to a large language model, you end up with billions of tokens, and this will reach the context length window. So small datasets are fine, bigger ones, you should not do this way. So, and now we ask BioBob, our AI assistant, okay, here's the data. Can you spot any data quality problems? Just give me a short list and explain them. And we hopefully end up with the same explanation we just found by eyeballing them. Right? And it also finds a couple of problems we already spotted, right? Inconsistent species name, there's sometimes an NaN for missing values, we have mixed date formats, we have invalid body mass values. This is something we haven't seen by just eyeballing because it's somewhere down the lines, right? There are inconsistent sex codes, sometimes it's male, sometimes it's M, stuff like this. But, and we may now just take this, put it in the data quality report for our data management plan whatsoever, and are fine, are we? If I ask it this way, we are probably not, right? Remember, large language models potentially hallucinate, right? So some of the things may be made up. We don't know, right? Because we don't know what happened in the large language model. This is a good starting point, right? But what we want to do right now is really checking the data against a schema which is based on those potential data quality violations, right? And doing this via Python code, actual Python code and Python libraries will end up in provable and deterministic results, right? If you ask the different large language model what data quality problems are in the data set, you get like different answers. But if you do it with proper Python code and you put in the same data, you get the same result, the same violations, which are actually there, right? So, this is something we want to do in the second notebook right now. We want to draft with our AI assistant proper Python code to check our data against a schema we predefine. And then we will definitely find all the violations in a deterministic way. Running it again and again will yield the same results. Okay, so this is just for you to remember. You can ask a large language model for such things, but you can't be sure if it found all the data violations, quality violations, or if it has made up some of them, right? Any questions up to here? Yes.
My AI doesn't work.
Okay. If it doesn't work, just show up right away, right?
I just got lost in this this step.
Runtime error.
Yes, I have the same problem.
Unknown model API for Mini. We need to. Okay, that's the problem. Somehow, so endpoint none, it did not load the correct environment variable in your case, and now we need to check this, and we need to check how you started it. You did forget this -- end file secrets, right? You did run JupyterLab, but you did not load the secrets file. Therefore, those environment variables holding the API endpoint URL and your API key aren't loaded, are not available. So we can just Control-C, stop it. So we are shutting down now, and we are rerunning this command, but we put we run -env for environment minus file, white space. And now what's the name of the file? It's this secrets, right? You write secrets and enter. And now UV starts JupyterLab again, but now it loads the secrets file in this process and provides all those environment variables, right? So we now have a new instance. And you may just check down here whether, if you run this right now, we should see now it has found the endpoint, and now this should also run. Okay.
Oh, I will do it.
Okay. So we now want to open the second notebook, right? What's the time? Right. Validating data. So we are in step 2 now. So we did the exploration on data quality. You may also do something like we did yesterday, like ask BuyerBob to do a full data exploration notebook for you with visualization, stuff like this. We will skip this for here, yeah? Right? We want to focus on validation and data quality reports. So this is a lot of text describing what I showed you with this icons. So we now want to use Pandera and Pandas to actually create a schema which we can check our data against, right? So our schema is a data contract. Again, for each and every notebook, unfortunately, that wasn't invented or implemented yet. We need to import our AI assistant again. This is something you need to do, unfortunately, for every notebook. And now we want to do the same we did in the notebook before. We load our data from field samples raw CSV into a Pandas data frame. And now we check, this is the command here, we check which data types Pandas tried to infer, yeah, right? Or which data types Pandas found. If we execute this, we will find the following: str, or in some cases, it also finds object like obj. So this is the most generic data type you can have with Pandas. And this is kind of a silent problem, I call it, because Pandas does not complain. It just loads the data, but we know there are numerical columns in there with floating point numbers. There are categories in there with just male, female. So, but Pandas just did everything is a string, like text, right? And this is a problem if you really want to validate data against the schema, when the schema says something like column for body mass is a number. Then this is a violation, right? So this is the first problem we found. We kind of need to find the correct data formats for our columns, and we want to transfer to the correct ones, right? Here again, if you don't know what this code does, you can again just ask Bob, what does this code do? Explain for a beginner, right? And this is something I want to encourage you. Just use the AI assistant whenever you need to. It kind of really helps, right? Sometimes it takes a bit longer, obviously. Quite a bit longer. Okay, while Bob is still trying to find a solution for this, I want to tell you about how we create such a schema, right? We start with kind of a data contract, which is just in plain language, text form, what we expect our data to look like, right? I prepared some. Does it work right now? It does nothing. Okay, we just do it again. Oh, no, it was this. Okay. This is sometimes the case. BioBob explains the code by creating the same code again. So this is sometimes the answers are quite mixed, right? Okay, but it tells what it does. Okay, so we want to have a look at the data contract. I already provided you one, which is plain text. It's located in data dictionary, or there's a file data dictionary, and it's a markdown file, and you can right-click, open with markdown preview, so you see the actual formatted text, and it looks like this. It's a bit big. I can just close it. So this is something I just did write down how I expect what the data should look like. It's up to you to define any other stuff, right? So this is the intended clean schema, and it should be a reference for validation and packaging, right? And our raw file actually deliberately violates a couple of those rules that we can see violation errors, right? So we want to have a field or a column sample ID. This should be a string because it's kind of a mixed pattern where we have a character and a number, for example. And this should be a unique identifier for each collected sample, right? And this way we describe each and every column, what we expect the data should look like, right? So for example, species should be a categorical string, and it should only be one of 3 predefined species in this case. The same goes for island. The collected date should be a date format according to the ISO norm, right? We have body mass. This should be an integer, a number, and it should be in between 2,500 up to 6,500 grams, because we know there are no bigger penguins, right? For example. And the same goes for flipper length and sex and region and so on, right? And we also have a column notes where we say, okay, this is actually a string, this can be free text, and there can also optionally missing fields, right? So this is just in plain text a contract, and this is just some notes I add. You can read this in full later on if you want to, but just to tell you, it makes sense to write down before what you expect from the data, what it should look like, right? So we have this data contract in this file data dictionary. And we now want to use Pandera to actually create a schema per Python code, which we can check our data against, right? So we want to have a code equivalent of what we right now have in text. So for this, we need to we need to import Pandera. We can try to import it right now. You should end up with such an error message, right? Because we did not install Pandera in our virtual environment yet. This can be done with the code cell above. We just need to remove this comment, hashtag as a comment, and then we can execute this !UV at Pandera. And UV takes care of installing Pandera in our virtual environment. That's quite fast. and we can now rerun this code cell, and yet Pandera is available for us. Great. Now that we have Pandera available, a library for creating schemas and checking data against the schema, we want to ask our AI assistant to draft code for such a schema. We don't want to do it by ourselves, right? And this is the next multi-line prompt. This is quite some text, but in the end, I'm asking BuyerBob, please write a Pandera data frame schema. That's the name of this schema object. Using this, import Panderas. We want to check against a pandas data frame. This is where we did load our data into, right? This tabular data handling. And this is just a short version of this plain text data contract we viewed just a minute ago, right? We have sample ID. This should be a string. It should be unique. It is not allowed to be null. It must match the pattern S followed by 4 digits, and so on and so forth, right? And then we ask our AI assistant, if you have created such a schema object, please store it in a variable, my Pandera schema. Just the code, no docs whatsoever, right? We can just force just code. If we execute this now, and if I scroll up, you may see we did use not the mini model, because that's not quite capable of programming potentially, but we use the coder model, right? This is something you may think about when using AI assistants. Which actual large language model, depending on the task, may I choose, right? So if we execute this, and you can do it for yourself, please, because we will end up with at least 8 different results, right? And it's going to be a bit longer text. Down here, while it's computing, down here I just described in text what the different building blocks are. It's still working. What the different building blocks of such a schema are. There are columns with a specific data type. There are optional variables which describe if values are nullable or not. There are checks, where we can check whether a value is in a certain range, stuff like this, right? And this is what BuyerBob created for me. I'm not quite sure if it looks the same for you, right? Or at least it should look similar, right? So, but we ended up, we didn't write a single line of code by ourselves. This is what BuyerBob did for us. And it did, I think, a quite well job. If we have a closer look right here, it's importing Pandera again. That's fine. It's importing all the objects we need from Pandera. Then it creates a variable called the exact way I ask for it, right? And then it implements the actual thing, right? We have a column sample ID, which is a column. It should be a string. It should match S and then 4 digits. It should be unique. It is not nullable. And there is a description already, right? And if you do not understand what this code does, you may just ask again, Bob, please explain this code for a Python beginner, stuff like this, right? So we end up with this. And if we execute this code cell, there are some warnings. We can just ignore the warnings. Warnings are okay. This is something called a future warning. Genau, future warning. In Python, sometimes software may exclude different parts of it in the future. And there are warnings already implemented in the code. Like, I right now use this and this method, but in future versions, this method would not or will not be available anymore. This is just a warning. The code works anyway, right? So we now have stored our schema in this variable. We can just copy this variable name. Down here, below, create a new code cell. That's a bit of a mess right now. So, but I just want to show you what we ended up with. And we can now print the content, right? And the content looks like this. This is just an object. You can kind of read it as an XML-like syntax, right? So we have a schema. This is of-type data frame schema, and here are all the columns listed with all the properties, stuff like this. This is what's stored now in here, right? So BioBob helped us to create a schema on code level we can check our data against. Great. But since you may end up with different types, I already let BioBob implement such a schema, a reference schema we want to use for the further work, right? But up to here, did you understand what we just did, right? If something is unclear, just raise your hand, we can discuss it. My goal is that you understand what we did. Okay, so for the actual schema violation checks, we want to use this reference schema. In the end, it's the same. There are a couple more comments, there are a couple more checks potentially, but in the end, it does the same and it resamples our plain text data contract we had, right? So if we execute this cell, we also have right now our reference schema, which resembles nearly the one BioBob creates for us. And we can also now ask BioBob, this is a to-do for later, to just compare the both schemas, right? And ask if there are any differences. So just that you know that BioBob created the same one I created a couple of weeks ago, right? This is a to-do for yourself for homework, for example. Okay, we now want to run the violation checks or the validation, let's put it this way. I prepared a couple of lines of code. What we first do, because we don't understand what this code does, right? We ask Bob, explain this code for a beginner. So since it's the coder model, the more sophisticated, bigger ones, such tasks take a bit longer right now. And it also may, we also may end up with, since it's a coder model, it was trained to generate code. It also generates code in such explanations, right? This code is a quality control checks. It tests your data in df. Here is our data stored against the rules you defined earlier in schema reference, right? So we run schema reference, validate our data. Lazy true just means do not show each and every violation right away, but collect them all first and then print them, right? So I'm going to remove this multi-line prompt and we just run this now as an actual code cell. And now we found 600 failing cases. We now actually did run or validate our data against a proper schema. And this is a deterministic check. It yields the same results for the same input every time you run it, right? So, and we can now check. Okay, how to read this? We have columns, we have checks, and here we have a number of violations, right? So for the column body mass, the coerce data type, so this means it should be, or the Pandera tried to coerce, find the correct data type by itself. This failed 23 times, so we have 23 times not an integer, a number in this column, right? One time it is not in range we defined, right? It's outside this range. There are 8 violations against this not nullable, so we have missing values in body mass. And the same goes for date collected. Here's a lot of them, right? Over 130 do not match our ISO date format, right? So, and the same goes on and on for flipper length, for island, whatsoever. So this is a quite good way, once you define the schema, to check data against. And next year, your researchers come again from a field trip, new data, you still have the schema available, and you can again check against the schema and find data violation, violating your data contract, right? So this is a nice tool for checking data violations. I think this is the code cell BioBob created while trying to explaining it. This is, again, I just did write down what I explained to you, right, how to read this. And we can now also use code to check concrete failing values, to have a look at those failing values to get a better idea, right? This is the next code cell. We may again ask BioBob to explain it, but if we run it, we can see for two examples, like species and body mass, what are invalid values within the data, right? So this is written with all caps. There are different, here for example, different typos. We have a lot of invalid values in body mass where this G is included, it's not just a number, stuff like this, right? So you are also able to check for separate values, which violates your schema. Okay, so ideas worth remembering. We just did detection right now, right? There was no cleaning. We did not fix anything. We just document the violations. And the schema itself is also a documentation, right? It is our data contract. You can just store it somewhere. You can also ask BioBob, for example, to make it vice versa. We have this code for the schema. Please provide me with the proper document describing the schema as a data contract. So, and you end up with an MD file, for example, right? It's all the way around. Okay, so we now want to store the schema. Since this is an artifact, we want to reuse in our data steward pipeline, and this is what this code cell does. In the end, you can also ask Bob to explain it. We create a new path, which is called outputs. If you now click to session 2, you will find a new folder, outputs. This is what the code just created. And it stored our data schema in YAML format, right? Not quite aware if you're familiar with YAML formats. It's also kind of an expression language, I would say. We can just have a look here. It's kind of JSON-like, right? So, and this is the schema we can reload into Pandera and check data again, right? But now we have a file. We can print it, actually, if you want to show it to others. And you can store it somewhere. You can package it with the data, right? And I think that's a nice tool. Okay, now it's your turn. I would say, let's just check. We have coffee break in 45 minutes. I'll give you like 10 minutes. The task is now to ask your assistant to extend the data contract, the schema reference, right? Right now, if we scroll up and have a look at the schema again, for each column, we only have, for example, one check, right? For the column region, we check if it equals Antarctica, for example. For column, what's a good thing? Body mass, we check if it's in range this. And you can now ask BioBob to extend this schema with checks you want to do, right? So, for example, if you think of, body mass shouldn't just be in range within this, we should also check whether it applies to whatever rule, right? And this exercise is just so that you get comfortable with asking BioBob to edit existing variables, right? So this would be something, for example, Bob, show me an extra Pantera check I can add to body mass column and this is this prompt augmentation. I provide the actual object schema reference so that BioBob can read it. And I also want to not just check whether it's in range, I also want to reject values that are 0 or negative. So stuff like this, yeah? And you can make up any rule by yourself. I give you like 5 minutes. So just that you kind of get familiar or comfortable with playing around with BioBob and Python variables. If I just, you can just execute this. So, and then you may also ask to actually do it. Provide me with the edited schema reference object. For example, this way. I just see it's also a nice explanation from our AI assistant, right? Rejecting 0 or negative numbers for body mass is physically, because they are physically impossible for living penguins, right? So is it working for you? Yeah, somehow. Sometimes the results may be, or sometimes you may reprompt if a result does not match your needs, or sometimes it's just rubbish. Actually, you ask for code, you just get text. You ask for text, you get code. Stuff like this, that happens. But you can just reprompt and also delete any outcome, right? Like I showed you yesterday, you can just right-click on an output and delete a clear cell output, for example, to get rid of the output, or delete the code cell which was created. But for my example, I just ask for another check which rejects 0 or negative values, which does not really make sense since we already check for a range, right? But just to show you. But it actually included this line here, right? It adapted the code a bit, right? There is not this range anymore. There is now greater than or equal, less than or equal, and greater than, right? So this, the additional check was included by our AI assistant. You now need to run, of course, run this code cell again and check the actual data violation, because you may end up with code which is not valid. That happens too, because it's just a large language model and it may fail in some cases, right? But this is just to show you how to work with your AI assistant within such a notebook to draft code, check the code, ask what the code does, use the code, stuff like this. And if you are happy with what you edited, what you rebuilt, you can now store this again as this data schema YAML file, right? To always have the most recent one. Okay, any questions up to here? Does anyone have problems doing this?
It's using international. Yeah, it uses large attributes, which is not defined.
Yeah, okay. And yeah, this is such a case where BioBob creates code which is not valid, right? Yeah. In this case. This happens, but you may do something like go to this, do the whole, for the code cell, and as a first line, make it a multi-line prompt. And now ask Bob, please fix this code. It actually may work, depending on the error message, right? Because right now, it gets erroneous code, it runs the code, it reads the error message, and tries to fix the code. You can just check if this works. This is also the case, like if you have erroneous code, if you have errors, just ask in the multi-line prompt, fix it, right? Okay, right now, we may have a 5-minute break to let some air in and then do the data quality report before the big breakfast break. Lots of breaks, break. And also, like, if you kind of don't know where to start at all, you just know, okay, I want to use Pandera, for example. You can just also ask BioBob, I want to use Pandera to check a schema. Please provide me with the full Jupyter notebook, which explains in Markdown cells what needs to be done. To always just put the next line of code, explain what this line of code does, stuff like this, right? To give you a full how-to on use Pandera. You can, of course, just read the official docs, but they are quite extensive and quite complicated from time to time. But you can ask BioBob to create a how-to on how to use Pandera for a total beginner. That's totally fine, right? I may just check what this looks like. Let's see. So, and in this case, BioBob created a notebook, Pandera How-To Guide for Beginners, with lots of text, what Pandera and pandas can do. It explains what the different lines of code does. If I need to import it, then there are examples. That's quite nice, right? How to define a schema from a very basic approach. Unsupported type, okay, that's a problem. But we may ask just Bob to fix it, right? Oh, we didn't. That way, we now need to add this code cell to import BioBob again for this notebook, and then we can ask Bob to fix this notebook, right? But that would be a way where you can use BioBob to build how-tos for yourself on your learning level, right? Or better, we just created it. Bob is able to run and check notebooks. We may just run it again. Oh, here. Then it would be good to leave the arrow as an output, so BioBob can read it. Let's see. Okay. We need to provide the full file name, right? Copy path. You just missed it. I asked BioBob to, because I'm completely new to Pandera, I don't know how to do it, so I asked it to create a Jupyter notebook, which is a beginner guide for using Pandera, right? So it ended up with such a nice notebook. I said totally basics, I'm a beginner, I have no idea. This notebook was a bit erroneous, right? This code cell yelled or gave an error. So I asked BioBob again to please fix this notebook. Now I have a second notebook, which is empty. Okay, so sometimes, but you get the idea of this cycling prompting, right? So you may ask to fix it again. Okay, cool. Any questions left to schema and data validation based on schemas using Pandera as just one option out of many in the Python universe, right? Okay, so let's go on to the next step in the, now we know about the schema violations, right? And we have a proper schema to check our data against. We want to build or create a quality report of the data. Now we know there are problems, right? This is done in the next notebook. It's a third quality report. Here again, lots of text, all the stuff I already explained via the icons. Here again, we want to import our AI assistant with our system prompt and the model coder to have a more sophisticated model. And now we want to use the Python library FG data profiling. I always link the official how-tos. If you just click on this, it opens the website. In this case, it's a GitHub repository, also linking to the documentation. Don't be mistaken, this is the former name of the library. For Python, it was just renamed to FG. But it does a lot of stuff where we can do, for example, data profiling and create reports and stuff like this. And as you can see, sometimes the official docs are quite overwhelming. So we may step back and ask BioBob to just explain us the basics for beginners, right? Because that's what our AI assistant is for. So we want to use FG data profiling to create a fully interactive HTML-based data reports with reports on data types, distributions, missing values, duplicates, correlations. It also plots a couple of stuff, so we have a nice viewable data report, right? Here again, if we want to use FG data profiling, we know we haven't installed it yet, right? So we want to use this line of code, uncomment it and run it so that UV can, no solution found, okay. Yeah, okay. And because your project depends on, we can conclude that. Okay, so this is a problem. We already installed pandas in the most recent version. So right now, UV is quite capable. It realizes, okay, I can't install FG data profiling because, and that's the point with the different virtual environments, because FG data profiling expects pandas up to 3.0, but we have installed 3.0.3 already. So there are two ways to fix this. First way, I just would try to ask UV to add both the same time and check whether UV can fix it. No? Okay. Then we need to do the following. We will create a new code cell above and ask UV to first remove pandas. Now it uninstalls pandas from our environment. And in the second step, we ask UV to install pandas and FG data profiling simultaneously, because in this case, UV will cross-check subdependencies, right? And this will hopefully not work. Great. Which is wild, because it worked when I tested it last week. Matplotlib. Okay. Depend on matplotlib, blah, blah. Okay, now it's matplotlib. Okay, we are one step further, right? So UV always tells us where the problem is. So we want to remove pandas, we want to remove matplotlib. And now we want to install this again, and now it works. So there were two problematic dependencies colliding with FG data profiling, right? So two libraries make problems if we want to use FG data profiling. The first one was pandas, the second one was matplotlib. They both were installed before in versions which make problems with FG data profiling. So if we remove pandas first, and if we remove matplotlib and then install pandas and FG data profiling again, then this works. Does it work now for everyone else? No. Then we may just check. Because I want you to actually print such a thing.
I try to remove matplotlib and it's like
okay, yeah,
fine.
Exactly. So it's already removed. You can just...
But then
And here you want to add FG data profile and pandas the same time, right? So just, yeah, exactly. And no, not end. You just list them with white space. Exactly. And if you run this, we just check. Because pandas is still there, we need to remove pandas first.
It's here.
So it now installed. Sometimes we can remove the probably unnecessary ones. And now we can run this again. This seems to look better.
And this means that it's working, or? Because there is no number, just
yeah, it's running. So this asterisk means it's running. It's calculating, and hopefully it's
Something different.
Fail to install package. Test. Record file. What? Oh, you are on OneDrive again. That was the problem we had yesterday. Because you don't have full installation and execution rights on OneDrive. It kind of worked because we did not do many installations, and because it now tries to create several files and execute some files, but on OneDrive you are not allowed to do this because this is kind of a cloud network and not your local hard disk. And now the question is, I would suggest that I'm not quite sure where you put it yesterday.
It was here. Yes.
So, but desktop is probably on hard drive actually. Okay, I can't read. Check.
This is open the file, share.
We can just check, and the full path. It's on OneDrive, right? So your desktop is on OneDrive. So we need to find. We may check this again. So I'm just showing the data quality report. It's in the end, it's just a one-liner, and it creates a really nice file. So that's just that you have seen it. Then we take care of this problem. Anyone else with problems removing pandas, installing FG?
Yes, I removed the matplotlib.
Yeah.
It's fine, but after installation and profiling, there is a problem with.
Okay.
I removed the pandas. I removed
Yeah.
the matplotlib.
We will remove pandas again just to double check.
There is a.
Okay, so and we now want to install pandas and FG data profiling in the same process. And this may
I forgot.
access denied. Data answer. Okay, oh, you obviously do not have full access. So this is access denied. It's right.
But this is the C.
Yeah.
It's the complete-
We may just check it again. I just show this data profiling once, and then we just remove the whole virtual environment and reinstall everything. And this should do the trick, actually. Okay, so you see there are sometimes problems, but UV tries to solve it in a good way. So what we want to do now is execute the next couple code cells. We import data profiling and import this specific object profile report. And then we use pandas again to read our raw field samples, right? This may take a while the first time. Takes quite a while, obviously. Okay, so
Again, I have a mistake or error. Just module, no module.
Because some of the lines are missing. Because import. Oh, some of the code cells are missing from your side. I'm just showing you afterwards, right? I'm just building the report now, then we fix all the problems, right? Because what you're missing is, okay, then it probably did not install properly. We will check it. So what does this code cell now do? We import pandas again to read our raw CSV file. We store it in raw this time. I just called it this way. And then now we use profile report to actually draft such an HTML data quality report on this raw data. And we call it field samples raw data quality report, right? This is done now. Now it's stored in report, and the next code cell just stores it as an HTML file. So this takes a while, and now we have, for the people where this worked, we just double check the errors right now. We have in outputs an HTML file data quality report, and you can just open it. And here, oh yeah, the problem is HTML is not really HTML-like in JupyterLab, but you may open it in a new browser tab. And here you have actual HTML with a data quality report covering lots of stuff. For example, we have some basic statistics on our data. We have the number of variables, we have number of observations, a number of missing cells, percentage of missing cells. Are there any duplicate rows? That's also an important information. Total size in memory, what kind of variables we have. We have text, categorical, and date time. And here we can already see we miss kind of numbers, right? So it wasn't able to coerce the data type for numbers. And then we can check for the different variables. That's the interactive nice part of this quality report. We can check for the different columns any more details, right? How many distinct species are there? How many of the distinct values? We can also check, for example, for string-like. This is a word cloud where the most common strings are the bigger ones and the smaller ones are not so common. And if you scroll down, you can also see some correlations if you came from statistics. So this also helps to see which variable correlates with another, right? And again, correlation is not causation, right? That's important. And if you scroll down, you can also see information about missing data, stuff like this. So you have a nice HTML file which provides such a quality report, and you can just send this quality report to any colleague. You can make a PDF out of it. Then the interactivity is gone, but you can print it if you want it, right? So this is quite a nice tool, and it's in the end, it's just a one-liner. Load the data, create the quality report by using FG quality report. And it's just one tool out of a whole universe of quality report tools in Python, right? Any questions regarding this quality report? Yeah, there are also alerts if you scroll down a bit more, and this cleaning we want to do after the break, right? So we can stop right now. I'm trying to fix the problems right now in the next 10 minutes so that we can go on afterwards. Because afterwards we want to ask Bob, okay, we now know about schema violations, we now know about problems which are stated in our quality reports. I can just show again the alerts, for example, right? Region has just one constant value, Antarctica, which is fine, but we have duplicate rows. We have missing values in island, we have missing values in date collective, and so on and so forth, right? And based on this knowledge, we want to ask Buyer Bob, please clean the data, just fix typos, reformat date types, stuff like this, right? Okay, so break, and I'm trying to fix the problems with the environment.
I tried to...
Okay, as I got it, all the problems were solved right now, right? Great. Was everyone able to create his, her, or her own data quality report HTML file? Not yet?
No.
Okay.
I just started this session.
Also, yeah.
I am here
Yeah.
going through the steps.
Yeah.
Before. Here is some error.
You actually need to run the code cells provided because so this was run, this was run, this was not run, right? There's no number, so this is missing. You can run this. And you may also, what you do is like this shortcut which runs a cell and then adds a new cell below. So you kind of start cluttering your notebook with lots of empty cells.
Yeah, that's why.
You may use Shift Enter, like Shift Enter, which runs a cell and goes to the next instead of creating a new one. Right? So we may just skip this because in the end, it was already done, right? So exactly. And this was the reference schema we provided. You can run this again just to be sure. And now you can run this validation where we end up with this 600 failing cases in the data matched against our data contract, our schema, right? Okay. Exactly. So, and we can also run this. This cell is, we look at some concrete failing values to check what's wrong. For example, like this typos, no capital letter, stuff like this, G instead of just a number, right? And this was this storing, exactly. And now there should show up an output here. If you click on session 2 once again, yeah. So there's this new folder with this file data schema output, which is this schema which can be reused for other cases, new data whatsoever, right?
Thank you very much.
Okay. I think we start anyway, although one is still missing, but I think he will catch up. Okay, what we did before, for the break, we just checked our data, right? We checked our data, or we validated against the schema, and we created a data quality report, which also did show some alerts, right? Missing data whatsoever. Now we want to apply a light cleaning. Once again, we don't want to invent new data where something is missing, but we want to have a consistent structure of the data with correct data types, no typos, stuff like this, right? And since we already know what's wrong, that's now up to you. I prepared such a multi-line prompt, which prompts our AI assistant to provide code to do the cleaning. Once again, we don't want our AI assistant to do the cleaning and give us a CSV back, because it may miss some cases, it may invent new data, it may hallucinate, right? We want code which can be run deterministically to do the fixing, right? So I prepared such a multi-line prompt, but in the end it's up to you. With all your findings for data violations and errors and problems, you need to write a prompt which asks our AI assistant, I have data stored in the variable raw, there are biological field samples, create code for cleaning that reads any missing values that are coded as, for example, all what showed up, right? So missing data in our case was either encoded as just white space, NA, null, question mark, -999, stuff like this. And we want this have consistently encoded as NaN. This is the Python equivalent for not a number. This is a proper value in Python which indicates there's something missing. Yes, and instead of all the different ones, we just want to have one. Then we want our AI assistant to drop exact duplicate rows. We don't want to have duplicate in our data. We want to strip white space from any strings, like from any text introducing or ending white space. We want to fix our typos where we know the controlled vocabulary. For example, Gentoo with 3 O's should be Gentoo, stuff like this. We want to remove the letter G from our body mass column, right? And all this other stuff we found. And also, please pass all the date formats you find and pass it into this correct format we want to use. So that's your part, actually, to write the proper prompt to get the code to do this. Yes?
In the item removes the unit J, it is better to define as leave only the numbers.
Oh, you may just try it out. So instead of writing remove the unit G, for the column body mass, just leave the numbers, remove everything else. Yeah. That's kind of, you may try it out. You may just edit your prompt and then check what's happening, and we can check. We will validate again afterwards, and then we check. And once again, we are asking a large language model. The more specific you are, the better the results will be. The more vague you are, the worse the results will be, right? So we can also put both into this one, like from body mass. We will put it this way around. So that's the point. This is prompting, and it's up to you how you phrase it, right? Remove the unit G, leave only the leave the numbers only, or leave only the numbers, and convert it to a proper number format, right? So
I mean, just leave only the numbers because of for the cases. When you have a mess of the G and other others.
Yeah. Okay. But we can still, you will try your version, right? And I will try my version. And then we just check how many validations are left after cleaning. That's quite, yeah. It always depends on your findings for data quality validations, right? And convert it to a number format. You may put this converted to a number format because just removing a G from a text still leaves the text, right? It's just a number with phrases, right? So you ask our AI assistant to actually transform it into a number format, which is integer, for example. Right? So we want to store our result in a new data frame, pandas data frame, named clean. Keep the code short and keep it readable with short comments. So let's see what it does. It may take a while. We will end up with a couple of lines of code. And as before, I already prepared such a reference. Oh, here we have connection timeout. Okay, this is nice. This means it's a problem with the endpoint. So it's a very long error message. Do you also have this?
Yeah.
Request timed out. Okay. let's just try. Oh, that's really long. Let's just try again. It always also has to do with the availability of your large language model backend, right? That there was quite an outcry. You may know Anthropic and Claude, like this large language model, which is okay. Timeout. Which is quite capable of like providing code, writing whole software, and lots of companies worldwide relied on it for their everyday business, and then for about 1.5 days it was not reachable anymore, and there was quite a plummet in like the DAX and whatsoever, right? So that's the problem. So we can't. That's the point. We can't use right now. We can't use our AI assistant anymore because the large language model endpoint is not available anymore. We may just check in this case. We will re-initialize it with the model mini. That was the very first code cell, so that it use a smaller model, which hopefully is available. It may result in not so high quality code, but we can just check.
But I have also problems with the internet connection.
Oh, so overall, let's just check. Oh yeah, okay.
Internet is unavailable.
Yeah. Okay. Well, that's great for a session which relies on internet, right? Okay, but not quite. That's the point. Okay, request timed out. So it's not the model. It is actually the backend. But I already provided a reference code for cleaning, so we can still work on it, right? We just can't use our AI assistant right now. I'm just going to clear the cell output. So we may end up with code like this. Again, if you don't understand it and we would have internet, you can now ask BuyerBob to explain what the code does. I can just explain. This one is we want to define or we are defining what missing values are encoded right now. There are lots of them, and we just want to replace all of them with this proper NaN, right? Then we read the data. Those are some options to not omit any missing data, but to really read it completely. Then we drop duplicates. This is a predefined method for pandas, which finds automatically duplicate values. Then we do this stripping of white space for a text. Then we replace any typo entries, like for example, Gen2 gets replaced with Gen2, stuff like this. Right? This is all what this code does. It looks complicated, but if you explain it line by line by an AI assistant, it gets quite clear. So we can execute it right now. And this last line tells, okay, we have this clean reference data set right now, and we just want to have a look at the first 10 lines. And here you can see missing data is now consistently encoded as NEN. We have not this Gen2, the 3.0 anymore, and also the date is now in a proper format, right? So this is basic cleaning you can do without really disturbing the underlying data. You are just apply proper formatting, right? So now that we have our basically clean data set, we can load out our data contract again with Pandera, right? And run the data validation again to check if the number of violations went down, which it hopefully should, right? So this is what this code cell does. Once again, if we would have AI assistants available, you can get this code explained. What it does is we read our data schema, which we created beforehand. This is now called schema. And then we validate our schema against the cleaned data. And we will end up with not 600 schema validations anymore, but only 110. And this is now properly missing data, mostly. So actual missing data, you can't handle this. This is up to the researchers. And there are still some things which couldn't be transformed into integer for body mass, right? And there are a couple of values which aren't in the expected range. But that's not up to you anymore. That's now the problem of the researcher. They need to check their data again. You did what you can for basic cleaning and validating again, right? So, and all this may, in the end, go into report, into like tasks for the data management plan, stuff like this, right? Okay, we can have a look now what still remains, right? We can see that the columns species, sex, and sample ID do not show up anymore. So those columns are completely fixed based on our goals. And we can check for the other ones, island, body mass, and data collected. There are missing values, and those left are those impossible or out of range measurements, like. And we can just print them, I think, just some samples of them. This code cell just takes the ones which couldn't be fixed, and we can have a look at it. And here we can see, for example, there are some out-of-range body mass entries, 13, and we just print the first ones. For example, this is too low, this is way too high. I want to see a penguin which weighs, what, 99 kilos? Right? So this is proper invalid data which needs to be checked by the researcher, right? Okay, so we now want to save our cleaned data. This is what we do here, right? We have our reference cleaned saved data, and we can use pandas to store it as a CSV file again in our output folder. We can check. Here we are with field samples cleaned for later reference, right? And for reusing it for reporting whatsoever, right? Okay. You can now again file a data quality report and check again what this quality report will look like. I'll just do it right away. And you will end up with less alerts, actually, right? And if anyone can, from then and then check whether the internet is back, then we can. So a question in between, just for my curiosity. Is this stuff which is potentially helpful for your work? Do you potentially apply this by yourself, or does it just help to understand the process and the tools so that you can educate any researchers, stuff like this, just to get to know whether this can be applied in your everyday work in any way, or if it's just interesting to see once, kind of?
I will probably use it.
Yeah.
I already does this, but
Okay.
and this will kind of easier.
Okay, cool. Nice.
And I will share it with my group.
Yeah, okay, cool. That's nice to hear. So for everybody else, it's mostly nice to know, and you know what others may talk about, or you can show others around and maybe propose that they can use this potentially.
I'm thinking about, I work in a library.
Yeah.
And maybe it would be useful for cleaning our data in our library catalog.
Yeah. Okay. Yeah. If this data is available in a fittable format, of course, sure.
Actually, I'm also producer of the numbers.
Yeah. Okay.
And is it possible to, I don't know, to perform? It's nice that you can get rid of the double or
Yeah.
the typos, and is it also possible to incorporate some like analyzing, I don't know, help?
Yeah, definitely. Like I said in the very beginning yesterday, these notebooks are mostly used for data science tasks, like data analysis, data integration tasks. And there are lots of libraries which help for like basic statistical analysis, plotting statistics, analyze data with machine learning approaches. So that there are loads of libraries supporting you here. It depends on what your goal is for analysis, for example.
Like statistics, I don't know, compared to groups of patients.
Yeah.
Make some graphs and.
Okay, we can just talk afterwards. Like I can just name you some capable Python libraries, but that's exactly the use case. This and Python was kind of or is used for worldwide in the last 2 decades, kind of.
Connection is one.
Sorry.
Connection.
Oh, nice. Okay, cool. My clean data report is also ready now, so I can just have a look at this new data report. There are more alerts now, but they are all about missing and this high correlation we don't really care about, right? This is nice. Sample ID has unique values now, so there are no double values anymore. So this is just to check again, and you can provide the quality report before cleaning, quality report after cleaning, and you can just collect all these artifacts you produce on your way through the pipeline, right? Okay, that's nice that it worked. So we now want to go on to the point of metadata, right? Because right now we have our data set, our clean data set, we have some quality reports, and we have a schema, all files, but we don't really have metadata describing our data to comply with the FAIR principles, right? And for this also Python libraries are available. I just picked one of them, right? So we can open for metadata packaging. And we want to use frictionless. Frictionless, there's lots of text just explaining what I just do. Frictionless is a library, a Python library, which helps creating metadata, providing metadata, and put it all together, data and metadata. And this helps to upload it to Zenodo later on, for example, right? Okay, so what we want to do again, at the very beginning, we want to initialize our AI assistant. And here we want to use frictionless. And since this is potentially not available already, we need to install it using UV again. And now I'm quite interested if this works quite well for each and everyone right now. You should hopefully end up with a success message. And if this was done, you can import frictionless and and the objects we need from it, right? Okay, so what can frictionless do? First of all, we are now working on our cleaned data set, right? Where we have correctly inferred data types, we have no typos anymore, stuff like this. And if we execute this code cell, we load our cleaned data into the frictionless object describe. This is just naming conventions. You can name it any way you want. And then we want to check for each column which actual data type frictionless now detects. And that looks way better, right? We don't have all strings anymore. We have proper data types for the according columns. So sample, species, and island are still strings, but we have date for date collected. We have an integer for body mass because it's a full number, and we have a float or a number for flipper length, right? So this is nice. We already have correctly inferred data types, which is one part of the metadata, right? This is important for researchers. If they want to download those files for their research, they can already check, okay, there are different columns, and column body mass is of type integer. I can work with this. Great. Okay, now we want to enrich this schema we have here, right? This resource thing schema. We want to enrich this with human-readable data describing the columns, because that helps for finding such data sets in any repository. So if I search for, I do research on penguins, probably some other researchers have already collected data. I will just research Zenodo, for example. And this metadata helps finding this, right? So we don't want to use it we don't want to do it by ourselves. So we ask Bob again. Frictionless is kind of a tool where you can create and put such metadata to actual data. So we ask Bob again, okay, I am writing field descriptions for a frictionless table schema describing penguin field samples. Then I list the columns. Bob should just suggest a one-line description, human readable, as metadata, which describes the columns, just the code, no other explanation whatsoever. So we may think by ourselves and write this down, or we let Bob create such metadata descriptions for us, right? It's just laziness in the end, right? But we end up with a describing sentence for sample ID, species, island, date collected, whatsoever. And actually, it also provides us with proper formats and so on and so forth, right? So we can use this for the metadata. I also provided this description references, but as you can see, it's quite similar, right? You may end up with a slightly different version, but in the end, we need a sentence describing each column. That's it. And now we use frictionless to put those sentences to the metadata, which describes our complete data. So we can execute this completely. You may also ask Bob, explain what this code does. Just short text, no example code. So, and then this is just a description of what this code actually does. It helps you to comprehend the code Bob has created, right? So, okay. What we have now is this resource object, right? So this resource object holds different types. First, it holds the schema, which also holds our metadata, and we can add more information. In the end, it's a wrapper for data and metadata, and we can put more and more into it, right? For example, we put a path. How is our file named into the metadata? In this case, our path is fieldsamplesclean.csv. You can also rename it if you want to. Then we want to package it, right? Where we create a package with a telling name, with a human readable title, with a short description of the data. We put in our actual resources object, which holds our description for the columns, right? Then we tell where this file currently is located from our view. We add a license, for example. We add any contributing people. We add some keywords. This is our whole metadata package. And then we want to store it in our outputs folder. This is, again, what this code cell does. You may ask again Bob to explain it line by line. And if we have a look right now in our output, you have data package JSON. And if we open it, you will end up with an actual JSON holding all the metadata to our data, which helps describing the data and which is compatible to, for example, Zenodo. Like Zenodo and other data repositories recognize this data package JSON format, right? And here we can just have a look. Okay, there are resources, namely the file, which is in format CSV. It's encoded in UTF-8. There is this schema with 9 columns, right? And column number 1 is sample ID. It's of type string, and there's a short description. So a complete metadata for our data, which is nice. We didn't need to write everything by ourselves. You can, of course, just start creating a JSON from scratch, right? But this was done by our AI assistant. Okay, and with this metadata package, we can reload it again. This is what's happening here. So this was one way to look at it, right? Open it in an editor and look at it, but you can also load it within Python code. This is just another way to plot it, print it, right? In the end, it looks like this, right? So this is just a part of it. So this is just to show you what the data package JSON looks like. Okay, any question up to here, like creating the metadata, after talking 2 days, like creating the metadata and put it into a package, right? And we can now use frictionless to actually validate whether our metadata is valid. Are there any errors within it, stuff like this, right? So we call package validate, and then we get a validation report, and we want to end up with our package our metadata package is valid, true, nice. If there are any problems, for example, I just want to show you something so that you get an idea. If I do this, so I don't tell frictionless where the file is located, this should create an error, I think. Yeah, so scheme error. There is no such file, because if I don't tell frictionless the file is located in outputs file name, it looks here. And there is no such file, right? So it really checks if the file is there. It reads the file to get the encoding, the file form and stuff like this, right? So this validation really helps and is useful, actually. So we put it back. Here we are. Okay, so what we did right now, we did 2 kinds of validations. The first one are on a value level against a schema. This was done by Pandera, right? We checked whether all the values in the data comply to our data contract, our schema. And then we check or we validate via frictionless whether the file matches as overall described metadata schema, right? So the one is on value level, the other is on file metadata level. And those both libraries play very well together. So also, again, I need to mention, these are just 2 libraries I picked from this whole Python universe. There are way more. You can also probably do everything with frictionless, but frictionless is quite complicated, especially if you start reading the docs, right? So, but I want to show you right here is also like this is a markdown cell. Like I did for Pandera, we may also just ask our AI assistant, Bob, create a notebook called frictionless how to which frictionless total beginner, not beginner. step by step. You get the idea, right? So if you don't know how to use frictionless, you may ask to provide a very beginner-friendly how-to Jupyter notebook which guides you through the usage of such libraries, right? Okay, so while Bob is running, we just want to wrap it up to here. We now have a single folder output which provides us with the cleaned data, which provides us with our data contract, our schema, which we can use again for later coming data. We have our data quality reports, and we also have our data package holding all the metadata for our data. So all those are artifacts which were collected and created on the way through our pipeline and which can now be put into any report, into data management plans, which can be handed over to other researchers, to colleagues. They can work with it whatsoever. And while Bob is also running, I want to show you that you also can provide your colleagues with all the notebooks you created, right? I mentioned it yesterday. For such a notebook, if you have it open, you can do File, Save Notebook As, or no, not Save Notebook As. There is Save and Export Notebook As, and there you can do HTML. For all the other, Markdown works, but for all the other cool stuff like PDF, you need additional software which which really strongly depends on your operating system. So you need to install it depending on your operating system. But what works quite well is HTML. So you get an HTML file, and if you open this with Firefox or with any other browser, for example, you get the whole notebook which describes the way you went up to here. And this can be easily printed or saved as PDF also, right? So you can fully document what you did, each step, and why you did it, right? So this is quite a helpful tool. Okay, so Bob is ready. We have our frictionless notebook. Just to show you again that this is quite helpful. And now we have a how-to notebook on the basic usage of frictionless. And you can do this with each and every Python library, which is, and that's the point, which is included in the knowledge of the large language model you are using, right? Because Bob does not support web search, like you can ask Gemini or whatsoever to do a web search to get the most recent documentation, but Bob does not support this. You can ask Bob, do a web search off, but then you get an error message because it can't handle the resulting web search results from the underlying large language model. So you need to mind the knowledge gap of such a large language model, right? Okay. So, nice. Any questions up to here? Cool. Then we are heading for the last part, and we are quite in time. That's nice. Okay, we now have all these artifacts in our outputs folder. It's just listed here again. Right? We have our field samples clean, data schema, data package, we have our report, and we also still know, because it's documented in our notebook, about the flagged issues, the still remaining issues in the data, missing data, and like this completely out of scope values we can't fix, right? And this is all which can be put into a data management plan for like how to handle the data any further. And either you write it by yourself, or again, like I showed you yesterday, you may prompt the AI assistant to at least give you that part of the data management plan as Markdown file, and then you can just put it over to docx or whatsoever, right? And I'm quite aware that there are other tools, potentially more sophisticated tools for handling data management plans. Like, as I got it, the Data Steward Wizard software is quite capable of this. So this may be just the pre-work before you then draft the full data management plan, potentially with another tool, right? I also talked to Joe yesterday, where we discussed the idea that you may call for example, the Data Steward Wizard software API to shovel any results from here directly via code into any project in Data Steward Wizard. This is something we may think about. So there are lots of possibilities, right? So once again, we are now on task for drafting documents. So Mini is all right. You may use Coder, but it takes longer and it may result in code, right? So we want to just select the Mini. And now we want to use our BioBob to draft this part of a data management plan based on our findings, on our files whatsoever. I already prepared such a prompt, right? You may adapt or edit this prompt given of what you know what a data management plan should look like based on any templates whatsoever. You can tell the underlying large language model, please follow the Horizon Europe DMP structure. Here it depends whether this large language model knows about the EU Horizon DMP structure, right? But any more modern model should have read it once, at least, while crawling the internet. And we want to store this draft in just a small markdown file, right? We just describe what we did. We just describe the files which were created, stuff like this. And if you run this, you will end up with such an example draft I put in here, right? This is just a data summary, the FAIR principles based on, or how the FAIR principles are achieved based on the files and the metadata we have, stuff like this, right? You may end up with another version, but in the end, BioBob will create such a DMP draft. We can open it with Markdown Preview. It looks a bit different, but in the end, it's just a description you can copy-paste and edit more in a way which helps, or which helps your goals, right? So findable, we have a persistent identifier. Or a persistent identifier will be created when we deposit it to Zenodo later on, stuff like this, right? This is what the large language model Mini created based on our files and our prompt. And it's quite extensive. It also includes the license, right? Okay. So, up to here, we are actually done with this session. What I'm going to show you now is the deposition to the Zenodo sandbox. If you are quite fast, because you need to register to Zenodo sandbox, it's another repository equivalent to Zenodo, but you need to have a registered account. And this is just a playground, yeah, where you can try, what does it look like if I post data to Zenodo? You get an actual DOI, which is only valid for such choice examples, stuff like this. But what I want to show you here is you can go the way by just using the browser, log in, writing everything there, and then upload the files. So that's one way. I just want to show you that you can do all this by code, right? You can call the Zenodo API by code, and you can use BioBob or any other AI assistant to draft this code, right? Here it is explained what you need to do if you want to do this at home. So as an example, yeah, register at sandbox.zenodo.org. There you need to create such a personal access token, which is the equivalent to an API key, right? And then you need to put this access token to your secrets file. And now I'm not quite sure if I put this access token to my secrets file, actually. I did not. So this is something I need to do now. And I need to check my password manager. All of you are using password managers, right? Asking as an IT security guy. So, and as you can see, this Zenodo sandbox personal access token is quite long. So I put it here. And it ends with, yeah. Okay, so we are fine. What I do need to do now is restarting JupyterLab, because this is a new environment variable we did not load yet. So I just do. Okay, so we want to relaunch it. And here we are. So I'm just guiding you through this code cell so that you have seen this process once. And if you want to do it by yourself, just register and then execute all those cells too. So what we do here, we import two Python libraries. One is operating system to read such an environment variable, and the other one, requests, is a Python library which can call internet pages for us, right? So we execute this. I found, or the code bit found that I have a valid token, so I can run the next one. This is, we authenticate against the Zenodo API. Yeah? We just call the Zenodo API, we give our access token, and then we create an empty deposition. You can do this in Zenodo if you are familiar with it. You can create an empty project, object, whatsoever. You can file for a DOI already before putting any data there, right? This is what we do here via code. So, and it created the deposition with the number this and this. This is the DOI already created. And if I just open this link, oh, I need to sign in, of course. Does it work? Okay, then this one. So, sandbox. Okay, so this is here we are, just open it again. Hopefully we are authenticated now. Great, so it's just a draft where I can put data and metadata, but I already have a DOI, right? And I can already watch it. Now it's up to me again. Okay, the rest I'm doing right now is via browser. I just upload the files, I put all the information, but we can still just resume using our code. Where is it? Did I just close it? Obviously. Wait a moment. We need this. Here we are again. Okay. So we have this empty draft, and now I want to upload my files to this empty draft where I already have a DOI. So I define which files need to be uploaded. I want to upload our cleaned field samples data. I want to upload the data package, and I can decide to put more there, right? If you also want to upload your quality report, you can just put it to the list, right? We can just do it. Quality report clean. We copy the path. So, and you can add way more files you want to upload to this repository, okay? And now we run the upload process. For each file we defined, use the requests library to shovel this data into this Zenodo Sandbox repository. It uploads, and we can actually check, right? We just reload, and as you can see, our files are now loaded into our Zenodo Sandbox repository entry with a valid DOI. It should be here somewhere. Somewhere. We will see it in a minute. Okay, and now we add some metadata. Do not, wait a moment. This is just like metadata you put, you would put here, like describing these fields, right? The resource type, title, stuff like this. This is what you do via code. Also, you can rename it any way you want. Okay, and now our draft is ready. We can have a look at it again. Now there's our title. We have defined our resource type. It's a data set. Our publication date is ready. The author is data steward, whatsoever. Every metadata you put there. And either you click publish here, or you can also do this via code, right? We confirm everything, and then we run published. So this is like the more complicated way instead just using the browser. But once you have kind of such a code-based pipeline ready, you can reuse it for every kind of data coming in and just run the notebooks, for example, right? So, and now we are ready. This is my test DOI, and this is my completely published dataset with metadata on Zenodo with the DOI. Fair principles achieved, at least to some extent, right? I can now I can redo this within the next 30 days on this Zenodo Sandbox. Otherwise, it got persisted and is findable by others, right? You can just check now if you want to. It's a bit small, but if you Google this Zenodo DOI, you will find my data package in Zenodo Sandbox. And that's actually the full pipeline, right? We got a first orientation on the tool we used. We used Pandera for creating a data contract, a schema, which we can validate our data against. Then we find rule violations on the schema. This is on value level. We can create a quality report with FG data report. We did a basic cleaning of the data. We validated again whether some of the violations were fixed. Then we document a data package or we create a data package with metadata using frictionless. And in the end, we can draft the content for our data management plan and upload it via the Zenodo API. This, what I did here with the sandbox, works exactly the same way with the actual Zenodo, for example, right? So, and that's from my side for today. Are there any questions left? Do you want to know anything else? Is anything unclear still? Yes?
I was a few minutes ago, so because I have some errors.
Yeah.
From the start, part A, I have like this.
Wait a moment. You can go up a bit. Oh, okay. You actually loaded JupyterLab without loading the secrets file. You can see this. If you run this, then this small output tells you which model is used, which endpoint is used. There's none. So it did not load a model because it do not know where the endpoint is. If you run this cell again, we can just check. Yeah. Okay, so we need to reload JupyterLab, but with this ---env file to load the secrets. Yeah, no, that's fine. I may just show you again from session 1 because it's documented there what you need to do.
Because I reloaded all the folder before
Yeah.
today because of the error. So
Potentially. So exactly. What you want to do is you have your secrets file with all this stuff defined, and you want to do this, right?
I already have the secrets file here, but
It's here.
probably
Yeah.
it's not loaded because I moved the folder to another folder. So
Yeah. Okay. So that's potentially the problem, right? So what you need to do is like shut it down, and once it has been shut down, we are here, I assume. Yeah, exactly. So you want to do,
with secrets.
yeah, we need to, minus, yeah. We tell you we run JupyterLab, but use as an env file, env, env minus file, yeah, and secrets, because this is what the command does. UV run JupyterLab, but use as an env file this.
Yeah, we did it yesterday.
Exactly, yeah.
I didn't do it for today. So,
Yeah.
So show the secrets would be.
Exactly. So, and if you hit enter now, it reloads JupyterLab, but now it will probably connect to the endpoint, and you can use the AI assistant. Okay. Any more questions regarding the content of the session? We may now probably open the curtains a bit. I think so, just that we see each other. Yes.
I have a question. If anybody has no question or proposal, I have sample data here.
Yeah.
A very small sample data set with marked problem.
Yeah.
If we can look at this data set and say together if the system should be able to indicate these problems.
Okay, so you have an example data set with you. Okay, yeah, we can just check it, actually. Also, from IT security view, never put a USB stick from any other person to a laptop, right? So, let's have a look.
The first one.
The first one, okay. So I just copy it, and we will put it to, let's session 2 data as a new data set, right? Wait a moment. I need to open where are we? Desktop, USC, sessions download, session 2 data. So, okay, here we are. So we have this new data, which is, what's the format? Okay, yeah. Oh, that's nice. That's nice. That's a good example because we can show that you also can use pandas to load an Excel sheet, actually. Excel sheet. We can, of course, JupyterLab can't open Excel, which is all right. We will check. First of all, in the data validation step, we will reload this. And now, I'm not a programmer, right? Bob. We just use Bob. So, data. We can just copy paste the path. Just to be sure, right? So, we call it equal, right? So, let's see. It now gives code, of course. We will execute this code and watch what happens. So that's a lot of code, but in the end it does what it provides the file path. It checks actually whether this file exists or not, otherwise it gives an error. Then it uses pandas read Excel. We will see whether this works. Okay, missing optional dependency, open PyExcel. Okay, we need to install this. So we do buff uv add. Ta-da. Here we are. So we have now read an Excel from our data folder, and it just shows the first couple of lines, right? It's just line breaks in within. Does it look familiar? It's like a magic show. Does it look familiar to you? So we have loaded now this file. It has 25 rows and 14 columns, right? Potentially. Okay. We can now go on. Now that we have the data loaded into a data frame, the pipeline now is the same, actually. It's just another data. So what we need to have here, or...
Yes, but I don't know to show you the step by step the working with file.
Yeah.
Just discuss
Yeah.
about the possibilities of indicating of that mistake indication in the files. For example, if you show there is incorrect. This is a sex, yeah?
Yeah.
Male, female.
Yeah.
And there is a mistake that one female is marked as a man.
Okay, we can just... yeah.
This is possible to indicate by the system.
Yeah, definitely. What I need from you to do the same what we did to my example file, you need to provide me with a data contract, like a data schema, which describes what the data should look like. In the end, we need to describe a schema which says gender should have only male or female defined as. Right? And if you define such a schema, we can run the same data validation step like we did down here, right? This lots of code in Inventor. We can run the same thing after than here. We just need to define this reference schema for your data.
So, for example, in Czech language,
yeah,
the women names are ending with OA.
Yeah.
So or A.
Yeah.
So it is possible to use as a rule to the system for indicate.
Definitely. Yeah.
Sex.
Yeah, definitely. What you need to do in your case, I mean, in the end, you can just ask BioBob the same I just did. Please load this Excel file just to test it by yourself. And then you will edit this prompt to create such a schema you can validate against, right? You need to write your own prompt for your data set, which we just loaded. I expect the column name to end with. Just describe it with human readable text and let BioBob create the according code, because there are code-based checks which do the following. Take a string and check whether the last 4 letters apply to your rule. It's all manageable. That can all be applied also to your data.
But for example, in German language, because there are ending OA in women names, how indicate that the name is a women name, not a man name?
Like how to do it in German?
Yeah.
Oh, there is no, like the short name or the first name?
Surname.
Surname.
In Czech it's typical that we have OVA at the end of the surname.
Yeah, okay.
Germans not.
No. In Germany...
How indicate that any name is men or women?
You can write this. Wait a moment. We just write it down once, so that you see what I would ask BioBob to create a schema check for, right? So Bob, write a Pandera data frame schema for a pandas data frame called. We just check again how I called it, just to make sure that we know which here, UConn. So, call UConn. It's not that big. We may also augment it, right? With data. Having these columns and rules. So for example, what was the column name for? I can just copy paste it, right? The store name. Which one is it? This?
This is not a separate.
No.
This is
Okay.
one.
But
Self.
okay.
There is a comma.
Yeah.
And first name.
Okay, so let's do this quite complicated case. We just have one column with surname, first name, right? So we just take this. Where's our prompt? So it's a string. It should not be unique because we may have two people with the same name, right? Not null. It's in format or last name, first name, right? This name must match. We can just make a line break here. Must match the pattern whatsoever. And then what was it? OVR, for example, right?
No, V. And with A with accent.
I don't have an accent on my keyboard, but you have, right? And that's the case. This is just the case if the person is female, right? So we can define this. Where the last name must match the pattern if the entry in column gender, I'm writing it in English right now, is female. So this is a human readable rule, and it's now up to BioBob to define a coding Python code enforcing this. We can just check what happens, right? It should create such an object, data frame schema. We now check just one column. No, we check two columns actually, like name and gender. And let's see what's coming up. Obviously, UCall dataset is not too big. Otherwise, we would have gotten an error with extended context window.
It's about 25.
So here I get key implementation details, what it does. The requirement, last name must match over if gender is female. Okay, cannot be enforced by a simple column level records, but it has implemented another way, right? So we now need to check what it does. So in the end, this is what BioBob came up with. This is our schema with our rules for this column. It's type string. It can't not be null. The basic format is last name, first name. There is space allowed. And this is a check. The string must match. And this is regex. This is kind of computational string checking, like a regular expression. We check whether our string complies to this rule. This is quite complicated. It just tells the computer the string must start with any letter. Then there are another letters. Then there should be a white space. Stuff like this. This is quite a complicated reg. I can't read it right now too, right? So this is like last name, and this is first name, right? So this comma, description format, and then we have this gender. I'm not quite sure if this is but it obviously BioBob picked up the data from the actual data set. It creates way more rules. We can now just check it, right? It obviously creates lots of rules for all the columns by itself, right? So I will just execute this. There are errors. Object has no attribute not nullable. So this is an error in the code, but I don't care. I just ask Bob, fix the code, right? Because Bob can read the code and Bob can also read the error message. Go on, do it. But that's exactly this iterative way I would go to, right? You try to, so now hopefully the code is fixed. Let's see. Still, okay. Attribute error, check. Object has no attribute not nullable. Where are we? Check not nullable. We just removed this. Lots of not nullables. So as you see, also like I use this mini model, right? Not Coda right now. So this mini model is not does not have the most recent documentation of the code, stuff like this. That's a lot. I need to check this again because but this would be the way actually, like you describe your rule to the large language model, to the assistant, and ask to provide the according code which defines the schema, and then you can run the same process like we did down here, and then check whether any columns violate your rule.
Yeah. And it is system able to work with some semantics? For example, in one column is a state.
Yeah.
For example, New Zealand, Argentina, Mexico, and so on.
Yeah.
And two items are mistakes because they are Scotland.
Yeah.
This is not a state.
Yeah. Okay.
Independent and the Canarian Islands.
Okay.
So is system able to indicate that Scotland and the Canarian Islands are mistakes and
whether Pandera checks realize that's not a proper state? Is that the question, or? I'm not quite sure whether Pandera is able to do this. You need to define what states are. In the worst case, you need to provide a list of valid states.
so,
Yeah.
Some vocabulary.
Yeah, exactly. Yeah, but if you have this vocabulary available, like download the list of all valid states worldwide, and you can provide this and let Pandera check whether all entries are in this list. That's possible. That's possible. Right.
I'll show you later some details from this, but.
Unfortunately, I will be here for lunch, but then I need to leave. Yeah, but you will find my email in the training materials, right? And you can just drop me an email, and I'm going to check this code anyway tomorrow. This afternoon I'm on the autobahn the whole time, but I'm going to check because now I'm interested. I'm going to check this code anyway, and we can just exchange further. But in the end, all you mentioned, Pandera should be capable of if you provide the right rules and vocabularies and so on, right?
Okay, thank you.
Can I have a hint? Please don't use that rule in general.
Why?
Because if there are data from my wife, it will not work.
Okay. So there are exceptions to this rule already, right? So, but you see, this pipeline is adaptable also to your data. The question is, and that's a question you need to ask yourself, especially if you do not have any programming experience, if you do not work regularly with this, and there are definitely other tools which help, especially also, I think Data Steward Wizard also helps schema validation, or has schema validation capabilities. It's up to you which tool you use. My goal was to at least introduce you to JupyterLab and Python tools, and which you potentially can use, especially with the help of such an AI assistant. And And now it's up to you to decide whether you want to have a more deep dive into it, educate yourself further, use it on a daily basis to get more familiar with it, or if it's just like, okay, that was interesting. If someone asks me, I can give some hints and that's it for me, right? So that's up to you right now. But I think I reached my goal at least. Yes?
I have such a problem with this because I think I keen off this system because I think it is very strong and efficient one. But I am not able to learn to work so deep with this system, so I am able to use it in normal working. Normal work.
Yeah.
So I go back to the Excel and
Yeah. I'm quite aware of this problem. Like it's also a question of time, definitely. Like if you want to make yourself more proficient with this needs time and like a daily exercise on it. Kind of, you need to use it really regularly to get more familiar with it. What may help, but this also takes time, if you kind of build up, for example, one Jupyter notebook, which does all the stuff we just did, where you just need to tweak a couple of entry points, like which type of data do I read? Is it an Excel? Is it a CSV? Is it whatsoever? So this is something adaptable. And the other thing is the data contract you feed into the system. Instead of prompting within the or instead of writing your data contract as a full text, you may write it in a markdown document and then just tell BuyerBob, this is the new data, this time is Excel, read it, and this is new data contract for this data, read it from the markdown file and create according text. And everything else should not change because we run the validation, we create a quality report, and we create metadata. We'll just provide some information. But also this, I'm aware of it, takes time to set this whole pipeline up, right? This, unfortunately, I can support you with some questions, but I can't set up a whole notebook for your work. Except you may employ me for a couple of weeks, right? So, as a side hustle, right? But yeah, it's doable. You can create such a notebook which is just the whole pipeline, and you just tweak how you feed data and information in it, right? Where you just provide 3 files: incoming data, data contract, and metadata information you want to provide for this specific use case. And then this hopefully runs through just once, right?
I have 2 problems because the data analysis is not my only work.
Yeah, of course. Yeah.
And we have a very heterogeneous data. So every project needs completely another structure.
Yeah.
Data.
But my suggestion would be, we have seen that BuyerBob is capable of generating whole notebooks. You may just provide BuyerBob with whatever the new data is, just an example or just some samples that the structure is clear, and then ask BuyerBob to, hey, I want to have a Jupyter notebook which does the whole pipeline with data validation, quality report, metadata, and upload to Zenodo. Provide me with a notebook. Then you don't need to do it by yourself. At least that's worth a try, and then you check for any code errors. But this helps to setting up this pipeline based on the actual data, right? You just provide a sample of the data so that the LLM gets an idea what the structure is and what potential problems are, and then let the large language model create the Jupyter notebook as an idea. So you don't need to do anything anymore.
And last question.
Yeah.
Make you some check that the system solution is correct.
The system solution.
Is correct.
Okay, you mean like we use Pandera to check against a schema How can we prove that this check is correct, right? That's the question. Well, that's a problem. How do you prove that the adding up function in Excel works correctly? How do you check this?
By mean of looking
At the
expertise. By
Okay, but let's say you have an Excel with or not billions, but with 100,000 lines, and you do some more complicated, like magic commands in Excel whatsoever. You just trust Excel, right? That it did the correct adding up stuff, kind of, because like Excel is a widely used tool and it's maintained from big companies, stuff like this. I'm quite aware that this may be not the case for most of the Python libraries, but you try to pick Python libraries that was the case in PyPy. Check for Python libraries which are maintained still, so last update 21 is bad, 25, 26 is good. You kind of, to some extent, need to trust the maintainers. You can, of course, just have a look in the code whether those schema validations are computed, because this code is open source, actually. But yeah, that's the same like for for Excel. If I use Excel and I do some complicated computations, I just trust Excel that it would be correct, right? So in the end, it's the same for any Python library you use.
Most of errors are generated by humans. Yes, so
Yeah, exactly. Yeah, and humans wrote the software actually. So again,
for defining variables.
Yeah.
Or the range of the data.
Yeah, exactly. So yeah, but in the end, it's up to you to decide whether or not you want to use a library and whether or not you trust it. But like I said, to set up this whole pipeline, you may use BioBob or any other AI assistant. Any online tool can do it right now, or at least the bigger ones. You can ask Claude or ChatGPT to create a notebook which uses this data and does the whole pipeline with validation, quality report whatsoever, and it just provides you with a notebook you can execute again and again and again. Okay, any more questions? Then we are done for today, and we are 5 minutes early. Isn't that nice? Thanks for your attention. I really hope you can take something with you, which potentially or hopefully helps for your everyday work. It was fun to teach you. Actually, it was also nice and interesting. There were some new things for me also, especially regarding, this is something this is some key takeaway for me. No OneDrive, this is something I will write down in the preparation steps, definitely. So yeah, thanks again.
Me too.